From the Brenna Bunker in the quarantine Piedmont of the southeastern U.S., this is Ace Academy, 7th, 8th Science. Alright, good morning, friends. Here we go, starting to teach from the Brenna Bunker. So you can see some more stuff sitting here beside me. Some the last couple of films I did, I noticed that there wasn't a whole lot of light on the backboard here, well, the whiteboard. And so what I did was I rigged this up to put some more light back right here on the board without having me a glare. So we're trying this. So if this works, I'll end up rigging these lights up without having these stands here for going in the future. But for today, we're trying it and seeing what happens. But for you guys in 8th grade, so we're starting a new unit today, 8.E.1.1, which is typically called the Hydrosphere. It says, I can recognize the distribution of water on Earth and organize it based on its location and type. So, water is the most common substance on this Earth's surface. Most common. On the surface. And you go, really, wait a minute, I thought there was a lot more rocks and dirt and stuff. Well, it says, on the surface. So this is stuff that's sitting on top of all that rocks and dirt and true Earth stuff. So the water is the most common substance on the surface of the Earth. Covers 71% of the surface. %71 of the Earth's surface is covered by water. Unfortunately for us, 97% of that water is salty. Just like ocean water, like you can imagine, salt water, nasty, you can't really drink it. Because if you drink it, it drives the water literally out of you instead of into you. The rest of it, only 3% is fresh water. Only 3%. So that's all the water that humans get to use on the surface of the planet consists of this 3%. Now, unfortunately, of that 3%, 77% of that is frozen in ice caps and glaciers. So of the 3% that is not salty, 77%, 3/4 of it, is frozen in ice caps and glaciers, basically unreachable by us. So that leaves 23% of the available fresh water on the surface of the planet that it is usable by humans in some form. Guess what? That's not a lot. I'm going to pause for a second. I'm going to erase this. If you need, remember, you're taking notes. You should be anyway in a notebook. You should be writing this stuff down as I write it down. Since this is on video, you can pause, rewind. Just make sure, when I start erasing stuff, it's not you're like, oh my gosh, he's erasing it. No, just rewind, copy it down, and then we'll go from there. So different locations have different water availability. Some places water availability is solely dependent on the weather. Water is accumulated in lakes and other naturally occurring above ground storage. Humans have added to this above ground storage with dams that create water storage and reservoirs. So we have So if you think about it, if you're in a desert, what's the main definition of a desert? Lack of water. If you're in a rainforest, what do you have a lot of? Water in the form of rain. So our ability to get and use water basically depends on what type of climate we live in. So, and most of it is due to, climate, which is, weather over a long period of time, not weather over a short period of time. Now, as humans, we've developed different ways of storing extra water for our use, whether it's through, to drink. So we store water in tanks for real short-term use, reservoirs, which is behind a dam, so that's how humans have figured out ways to store water. Water is also stored below ground. We call those aquifers. In many cases, the water supply, these dams, when we create these water supply, these reservoirs, they also supply us with hydroelectric power. And they also control flooding. One of the largest dams ever built, it's called the Aswan Dam on the Nile River, was built primarily as a flood control project because the Nile flooded every year when the spring rains came. So they built this monstrous dam on the river to control the flooding, and also created a huge reservoir of fresh water for them to be able to use there in Egypt. So in some places, it also creates a navigable river. We use these dams, and it creates not only, again, reservoirs of water, but also it changes the way the river is to the point where we can now navigate the river. In the United States, we had the Tennessee Valley, Tennessee River, which came up. You went up the Mississippi, and then the Tennessee joined the Mississippi. You could go up the Tennessee a little bit, but then you ran in all these shoals, and you had to stop. But they created a system of dams that raised the level of the river in some places and created a navigable waterway way up the Tennessee, in addition to creating a lot of water storage to be able to use for not only hydroelectric power, but also consumption there in the Tennessee, Georgia, North Alabama region. So, protection of clean, fresh water is one of the most important things. As again, we go back to that 3% because there's so little of it. That's why it's so important to have things in place that go towards keeping our water clean. And one of the reasons that the United States is gifted, and is blessed as it is because we do have regulations and things like that make sure that the water we do have stays clean, and we take care of our water. So let's look at that. We'll erase it and go on. Now, the other type of water on the Earth's surface is salt water. Also known as saline. Due to all the medical stuff going on right now, saline is something that's actually kind of important. Salt water. Because salt kills germs. Kind of cool, huh? The oceans of the Earth are all salt water. Remember, though, that even though the term is salt, do not think of it only as the salt of like table salt. The saltiness of the Earth's water is because of a multitude of things that go into it. So don't just think of it as table salt, which sodium chloride. Sodium chloride is what we think of as salt, so it's not what is the only thing that's in salt water. The salt in the oceans is a combination of a number of elements that combine to produce the water we refer to as salt. The official term for saltiness of the ocean is salinity. not the Earth's water, of saltiness of water. Salinity is the measure of the saltiness of water. So inorganic salts are compounds such as the familiar NaCl. And again, so the salt that goes in there is what we call inorganic salts. So NaCl, sodium chloride, which is what we're familiar with, and others such as magnesium sulfate, potassium nitrate, and sodium bicarbonate. Those are all different types of inorganic salts that we end up finding in naturally occurring seawater. In all, there's about 8 major and 7 minor components that make up the salt in the salt water. And then they make up the 8 major, 7 minor. So there's NaCl, magnesium, there's the top 4. And then you got about 4 more that are, quote, major, and then 7 minor components. We're not going to be quizzing you on what those are, but just be aware that there are about 15 different things that make up the saltiness of the water in the ocean. So when we measure salinity, so typically seawater measures about 35 parts of salt per 1,000 parts of water. So seawater measures about 35 parts of salt per 1,000 parts of water. This is an average of all the oceans. So there's variations are going to exist. So if you've got a coastal area or someplace close to where a river, a freshwater river flows into the ocean, those places, the salinity is going to be less than this. And then you have other places that have higher salinities based on water evaporation, shallow seas, that kind of thing. So there's a variation, but the average of all the Earth's oceans is 35 parts per 1,000. So, freshwater. So let's do this. I'm going to move this up here. I'm going to say PPT, parts per 1,000. So freshwater is considered between less than 0.5 parts per 1,000. The term brackish water, brackish, ISH, and that actually is the term brackish, is between 0.5 and 30 parts per 1,000. Saline water between 30 and 50 parts per 1,000. And then briny is above 50 parts per 1,000. briny, like salt brine or brine shrimp. That's where that word. So you got fresh water, brackish water, saline water, and briny water composing up the different types of water based on salinity. Excuse me. So the Dead Sea is often thought of as one of the highest naturally occurring briny water bodies, with concentrations averaging 337 parts per thousand. That's a lot, so think about it. So the ocean water is on about 35. So you can imagine what water that's 337 parts per thousand, how salty that really is. But that's not the highest. The highest recorded salinity is a desert watering lake in Ethiopia with 433 parts per thousand. Highest recorded. It's 433 parts. A desert water hole. (433 parts per thousand). That's almost half salt. That's remarkably high salinity. So anyway, so sources of the salt in the seawater are enormous, are varied and everything else. So we all have this. We're going to erase this. And remember, if you didn't get that all down, just hit the rewind button back a little bit, and you can keep copying as I talk about the same thing again. So sources of salt water. So, dissolved chemicals from the crust. So as things happen, or the crust is eroded, water flows down, takes the pieces of the crust with it, and through the process of erosion, washes that stuff into the ocean, and chemically it becomes salt in the water. Solids and gases. Ejected from volcanoes. You're like, how in the world does something thrown out of a volcano become salt water? Well, again, you're talking about chemicals from the crust of the earth. A volcano, but number one, liquidizes it, makes it magma. And so now, as it erupts, it blows all that stuff into the air, especially early in the eruption when it's blowing all that steam and smoke and soot. Those are all chunks of, really small chunks of earth being blown in the air, carried by air currents, and then it ended up depositing itself across the land and into the oceans. And even when it gets deposited on the land, water washes it into the rivers, which washes it into the seas, which then becomes, again, part of the salinity of our oceans. Hydrothermal vents. Deep under the ocean, hydro means water, thermal means heat. So deep under the ocean, there are cracks in the crust where the tectonic plates are spreading apart and being formed. And so these are places that are really close to magma, that's just real hot, molten rock deep under the surface of the earth. And so water seeps down into these things, gets heated, and then flows back up because hot things do what? They rise. So the cold water seeps down in the earth, gets heated, and then rises up through what we call as hydrothermal vents. And that hot, superheated water erodes the stuff down there and that newly forming crust and takes those minerals up into the water system with it. Again, and they say that the entire ocean volume can be cycled about every 10 million years through the active hydrothermal vents on the bottom of the ocean, Well, 10 million years. Well, that's kind of a long time, but you got to remember 73% of the Earth's surface, 71% of the Earth's surface is covered by ocean. That's a lot of water. And so for the entire thing to cycle in 10 million years, that's actually, quite amazing. So over the course of 10 million years, every piece of water that's in the ocean has gone down, been, absorbed a bunch of minerals and been ejected back into the water as hot water from these hydrothermal events. So these are the reasons we have salt water in our ocean. So dissolved chemicals from the crust, solids and gases ejected from the volcanoes, and the hydrothermal vents. So it's going to be the end of our first day of hydrosphere. So remember, I can recognize the distribution of water on the Earth and organize it based on location and type. So distribution of water means percentage of it. Where is it? 71% is in the ocean. 71% of the surface is covered by water. 97% of the water on the surface is salty, ocean water. 3% is fresh. Of that 3%, 77% is frozen in ice caps and glaciers. The remaining 23% is liquid and available for use by humans. And most of that is underground in aquifers. So, this is the end of the Hydrosphere Day 1. We'll see you guys later. I guess that ain't gonna play. Have a good day.